It's a cucumber. So, So where did this like log off? Because I don't know where we logged off. Did you guys at least see this in your notes? What was the last thing in your notes? Right before I graphed on the line? Okay. So we got to this point, right? Applying the fundamental theorem of absolute values. Notice that if you separate it, so it confuses me when I look at it like this. If you separate it like this and that, we notice that x is less than -7 gives us this stuff. And you notice that x is greater than 1 gives us this stuff. So how do we write this in integral notation is we write this piece union this piece. So this first piece right here is like -infinity all the way to -7. Is it included? Nope, not included. So I put parentheses, union, not included 1 all the way to infinity. Not included. Does that make sense? Let's see if this works. Let's pick a number that is greater than 1. Let's say 2. Plug it into here. Oh, man. Oh, man. I created a problem that cannot happen. Forget what I said here because notice that the absolute value of anything is a positive number and it can never be less than a negative number. So over here, everything we worked out for this problem is false mathematically. So let me create a problem that's not false mathematically here. Okay? And all we got to do that is make sure that the absolute value of something is not less than a negative number. The absolute value of everything is a positive number. Absolute value of a -100 is a positive 100. So how can the absolute value of any quantity be less than a negative number? Okay, that's where we should have known that there was something going on there. So that's wrong. But we can apply the fundamental theorem of absolute values here to get this. Okay. Now this is correct. Now I can subtract the 3 from both sides. So I get a -7 over here. I get an x, and I get a 1. Okay, so now we'll draw out a real line here. Here's our 0. Where's our other points of interest? There's this -7 over here. There's just 1 over here. And saying x ranges between these two. All right, and it doesn't include them. So it's this and this. So this interval can be expressed as such. Yeah, because when you take the absolute value of anything, it has to be positive. So the fact that I said it has less than a negative number didn't make sense mathematically. Yeah, my bad on that one. It was a good thing I caught it. What about a compound inequality like this? We want to solve for x. Okay. Actually, I want to come up with a different example to save myself like errors that I may have not thought of. Let's use a well thought out example. Yeah, let's use a well thought out example, not one on a whim. Okay. So let's solve for x in this situation. Well, what we can do is right off the bat, I can subtract the 3x from all these sides. Then I just get 1 is over here. This becomes a 4x minus 2. And this becomes a 2x minus a 10. All right. Then I can subtract the 2x from all 3 sides. But then I get 1 minus 2x over here. And I get 2x minus a 2 over here. And I get a negative 10 over here. All right. So what I could notice is in this middle term, I can rewrite it like this. Can we not? I just factor out a 2 out of each of those terms in the middle piece. Moving our calculations over here. Notice that this is kind of begging us to divide all 3 pieces by 2. Just so these 2's cancel. So the middle piece becomes this x minus 1. The far right piece becomes a negative 5. And the far left piece becomes this 1 minus 2x everything over 2. Okay? This is great because now I can subtract the x from all of these sides. And I get 1 minus 2x all over 2 minus the x is greater than negative 1, which is greater than negative x minus the 5. Okay? So then when I multiply both sides by 2, top and bottom here by fancy number 1, 2 over 2. What this becomes is 1 minus 2x minus a 2x all over 2 is greater than negative 1, which is greater than negative x minus 5. And this gives me 1 minus 4x, everything all over 2, greater than negative 1, greater than negative x minus 5. Is the last part n? Never mind. Okay. Notice that when you try and solve these inequalities simultaneously, you keep going down a rabbit trail. You're like, okay, let me subtract the 3x. What happens? Uh-oh. Let me subtract the 2x. What happens? Uh-oh. Let me factor out a 2. Let me divide by 2, and I get this, and I get that, and I get this, and I get that. But there's always an x here. There's always an x here. I can't combine them. Even if I were to add an x, add an x, add an x, I would get negative 1 plus an x. There'd be no more x's here, but there'd be x's here, and it's still annoying because you can't solve for x. So what we realize here is that using this method does not allow us to solve for x. We can't solve for x using a simultaneous compound inequality. Okay? But what we can do is rewrite the original inequality, this 3x, or 3, what was it? 3 plus x greater than 7x minus 2 greater than 5x minus a 10. What we can do is say, okay, doing it all at once is not working out. Why don't we do it piece by piece? Piece number 1, 3, because when we did it like this, it worked out. Here's piece number 1. Here's piece number 2. Let's try this. Instead of trying to do them all at once, let's do this, which is taking the far left with the middle, and this, which is taking the far right with the middle. Now I think it'll work. Subtract the x, I get 3 is greater than 6x minus a 2. Add a 2, so I get 5 is greater than 6x. This implies 5 over 6 is greater than x. Oh, now let's move on to here. Let's subtract the 5x from both sides. I get 2x minus 2 greater than negative 10. So I add a 2 to both sides, so I get 2x is greater than negative 8. Divide by 2, I get x is greater than negative 4. So now we combine these two pieces of information in one graph. Where's our 1 at? Here's our 1. And our 5 over 6 right here is slightly less than 1. So this is going to be where our 5 over 6 is at right here. Where's our negative 4? Our negative 4 is right here. Now let's think about these relationships. This is saying x is less than 5 over 6. Okay. X is less than 5 over 6. So I put parentheses because it doesn't include it like that. Over here it's saying x is greater than negative 4, but it doesn't include it. So I'll put some parentheses here. Here x is all the values greater than negative 4. Then we notice that what happens when we fill it in. This space right here. Okay, so this space is in interval notation done. When would you flip the inequalities? Whenever you multiply or divide by a negative number. Whenever you multiply or divide by a negative number, that's when you do that. So for instance, let's say we're doing a calculation. Let's say we're doing a calculation where we're like, okay, negative 3x minus 2 greater than 5. All right. Let's say I added 2, I get negative 3x is greater than 7. When I want to solve for x, I have to divide by a negative number. I have to divide by negative 3. So when you do that, you flip it. Have I explained to you why multiplying and dividing by a negative number flips inequalities? Because until this day, you guys were just told to do it. Oh, multiply and divide by a negative number, flip the sign. But do you know why? Did anyone ever explain that to you? No. It's a shame because it's actually really simple to understand. And you guys, even at the level of mathematics, you guys know you can understand it. I'll be right back and I'll explain it. All right. Time to explain why multiplying and dividing by a negative number causes the inequality sign to flip. As I said before, it's a very simple explanation that you guys could understand, that you guys should have been taught, but you weren't, which is really annoying. Let's say we have the real line. Let's say we have a 0 here. Let's say I have two numbers. Let's say I have a number A and a number B. Okay? Clearly, we can see that right here, A must be less than B, right? By the way, we've seen it. But notice that, what if I took the negatives of A? Negative A would land here. And negative B would land here. Would it not? You guys following me so far here? If A is like this much forward, then its negative would be that much forward in the backwards direction. And if B is this much forward, then negative B would be just that much in the opposite direction. Would you guys agree? No, you don't agree? Oh, you with me? Teach. Yes. Yeah. Oh, it's not teach, it's tia. What you mean? Yeah. Okay, good. Notice what equation I get here. I get negative B is actually less than negative A. Would you agree? Notice that traveling from here to here, the mathematical operation that occurred was multiplication by -1. Meaning negative A is less than, meaning A is less than B if I multiply it by -1. And let's say we don't flip the sign, okay? Let's say we don't flip the sign. We would get negative A is less than negative B. Let's say we don't flip signs when we multiply or divide by a negative number. But that would contradict this statement right here. Negative A being less than negative B actually contradicts reality. Take a look. Negative A is actually greater than negative B. So when you multiply or divide by a negative number and you do not flip the sign, we must flip the sign, you lead to logical contradictions. Again, that's why you can't. That's why you can't multiply or divide by a negative number and not flip the sign. You have to flip the sign, or else you get a erroneous statement like this right here. Does that make sense? What about the numbers 3 and 4? Would you agree that they look like that on the real number line? Okay. So then -3 should be here, right? And -4 should be here, right? So would you agree that 3 is less than 4? And then would you agree that -4 is less than -3? Notice that if multiplying both sides here by a negative number, like -1, let's say we do not flip the sign. Let's say multiplying both sides by a -1 doesn't flip the sign. So I just get -3 is less than -4. Is that true? Is -3 to the left of -4, meaning it's less than -4? No. -3 is to the right of 24. So this would be a logical contradiction. So in order for it to be true, we would have to flip the sign. Whoop, flip, whoop. So how does it feel knowing why you do it? Does that make sense? Yeah. Mm-hmm. Why could they not have told us this when we were little kids? It's such a simple thing. It is so simple. Why couldn't they have not told us this when we were little kids? It should make us really upset at the educational system that they didn't do this. And I, for one, am very upset. If we explain these things to people learning it for the first time, it wouldn't seem so arbitrary anymore. Now, you can tell your friends that you know why. If you multiply by a negative or divide by a negative, why you switch the sign. You'll be able to tell your friends, I know why. I hope that you guys go and show your friends this stuff. Please, please go show your friends this information. Because if you tell a friend that they tell another friend, they tell another friend, then the world will be better at mathematics. And that's a better world to live in. What about y is equal to 1/2 times the quantity? Absolute value of 4x minus 5. And let's say this is plus 3. Okay. So actually, this is a graphical problem. So they expect you to graph this. So I have not talked about how to graph these things yet. So maybe I should talk about that. And this will be the last thing that we talk about at section 2.7. So after this, we can talk about review. Okay. The graph of the absolute value of x. I'll give it to you, and then we'll derive what it looks like. It looks like this. This is f of x. This is the absolute value of x. Why? Well, to do that, you create an f of x table. Every time you want to know how to graph something, you create an f of x table, and you plug in values for negative. You pick some values to plug in and see what that outputs. So f of -2 is the same thing as absolute value of -2, which is +2. F of -1 is the same thing as absolute value of -1, which is +1. F of 0 is the same thing as absolute value of 0, which is 0. F of 1 is the same thing as absolute value of 1, which is 1. F of 2 is the same thing as absolute value of 2, which is 2. So notice that for -2, I get a +2. I put a dot. For -1, I get a +1. I put a dot. For 0, I get a 0. I put a dot. For 1, I get a 1. I put a dot. For 2, I get a 2. I put a dot. That's how you get that. So, what about something like this? What does f of x is equal to the absolute value of x minus 3 look like? Again, you can create an f of x table, pick some values, our symmetrical values about the origin, okay? And then we'll tabulate the results and then graph. So f of negative 2 is just equal to the absolute value of negative 2 minus 3 absolute value. That's negative 5 absolute value, which is positive 5. F of negative 1 is just the same thing as negative 1 minus 3 absolute value, which is negative 4 absolute value, which is positive 4. F of 0 is just the same thing as 0 minus 3 absolute value, which is negative 3 absolute value, which is positive 3. F of 1 is the same thing as 1 minus 3 absolute value, which is negative 2 absolute value, which is positive 2. F of 2 is the same thing as 2 minus 3 absolute value, which is negative 1 absolute value, which is positive 1, boom. Now we're going to play a game where we graph it. Okay. So you'll notice that I'll pick negative 2, negative 1, 1, 2. Okay. So then I'll go to negative 2. I'll find positive 5. 1, 2, 3, 4, 5. Negative 2, positive 5, put a dot. Negative 1, I see a positive 4. Negative 1, positive 4, I put a dot. 0, I see a positive 3. I go to here, I put a dot. 1, I see a positive 2. I go to 1, I put a 2, put a dot. I go to 2, I see a positive 1 right here, I put a dot. And notice that we can keep going. What about for 3? What about for 4? Well, f of 3 is the same thing as the absolute value of 3 minus 3. 3 minus 3 is absolute value of 0, absolute value is 0. And what about f of 4? Well, that's the same thing as 4 minus 3 absolute value, which is the absolute value of 1, which is just 1. So notice that at 3 and at 4, at 3, it's going to touch the x-axis. And at 4, it's going to bounce back up. So when we connect the dots, we get what we had before. But look, it just moved. Recall, absolute value of just x looked like this. F of x is equal to the absolute value of x looked like this. But this guy is f of x is equal to absolute value of x minus 3. It's as if the minus 3 picked up the absolute value of x, moved it over to the right, 1, 2, 3, and put it down. So, what would f of x is equal to the absolute value of x plus 2 do? What would it look like? Well, you're right to assume that if that minus dragged it to the right, that plus will drag it to the left. And I'll prove it to you using, you guessed it, an f of x table. My f of x is now absolute value of x plus 2. I'll create an f of x table. Let's plug in symmetrical values about the origin. Let's say, actually, let's move a little bit to the right. Let's do negative 3, negative 2, negative 1, 0, 1. So f of negative 3, same thing as negative 3 plus 2, absolute value. That's negative 1 absolute value, which is 1. F of negative 2 is the same thing as negative 2 plus 2 absolute value, which is 0 absolute value, which is 0. F of negative 1 is the same thing as negative 1 plus 2 absolute value, so that when you add them, you get absolute value of 1, which is 1. F of negative 2 is going to be negative 2 plus 2 absolute value, so then you just get 0 absolute value, which is equal to 0. F of, oh wait, this is negative 1, this should have been 0. F of 0. So actually, this is changed. F of 0 is the same thing as 0 plus 2 absolute value, which is 2 absolute value, which is 2. And F of 1 is 1 plus 2, which is 3 absolute value, which is positive 3. So then let's go over here, let's look at negative 3. -3 is right here. I go to -3, I find a +1, I put a dot. I go to -2, I find a 0, I put a dot. I go to -1, I find a 1, I put a dot. So actually, yes, it did it. Although my drawings aren't perfect and they're not drawn to scale. So we are officially done with 2.7. Now it's time for review. So we might be getting kicked out of this meeting pretty soon. Yeah, in like 2.5 minutes. So think of some questions and I'm here to answer you for the test. You can look on your syllabus to figure out which sections will be on your test. But since I have it up, I'll just let you know. The sections that will be covered on the test is, or they are 1.2, 1.3, 1.4, 1.5, 2.1, 2.2, 2.4, 2.5, 1.7, 2.6, 2.7. So it's basically 1.2 all the way to 1.5. Then randomly it skips 1.6 and it goes to 1.7. And then it goes from 1.2 or 2.1, 2.2, it skips 2.3, it goes to 2.4, then 2.5, 2.6, 2.7. I don't know, Tyler. I can't answer that question. I'm not sure. I actually can't tell you. A better way to gauge that is to actually take like the practice tests. Yeah, I can't tell you that. I don't know the answer to that question. So. How is the homework coming along? Are you guys doing well in the homework? Is it making sense? Do you guys want to do any homework problems that were confusing? We'll be getting kicked out of here in less than a minute. So pretty soon this thing is going to kick us out and then I'll give you re-entry. So by that time, I hope you guys have thought of a question for a review. If not, then yeah, class will be dismissed at that point. But we still have an hour remaining in class. So if you guys require some help and you need my assistance, you should use that. I'll give you every opportunity to use that.